Hello and welcome to the YouTube channel D Creations Resources. We are looking at different concepts from mathematics. Today let us see about the concept of types of relations. Now this concept usually is taught in 12th standard, but it's useful of course whenever you keep using calculus and so on and so forth. So we have already seen what are relations. So if you recall, we have already done an episode on it about functions and relations where we saw how relations are connection between sets. It's a set of ordered pairs. So as you can see here, for example, this set R, right? It's a relation. So 1 is related to A, 1 is related to B as well, and 2 is related to C. And so basically input 1 has 2 possible outputs while input 2 has 1 possible output, and each pair is connecting an element from one set. So the set could have been 1 2 and the other set could have been ABC. So element from one set is connected to the element from the other. And now coming back to the type, there are going to be two very trivial types which are called empty and universal. So if there is no ordered pair which is following the rule that is expected to follow, it's an empty relation. Or if it is true for every ordered pair, then it is called universal relation. But now we are going to focus on equivalence relation. So what is an equivalence relation? Well, it's a binary relation of course on a set. And in order to be equivalence relation, it has to be reflexive, symmetric as well as transitive. So what do these mean individually? So in reflexive relation, every element is related to itself. So for example, if you consider the order pair A is related to A. Now in case of symmetric relation, if A is related to B, then B also has to be related to A. So you can visualize, right? It's symmetry. What about transitive relation? So if A is related to B and B is related to C, and then if A is also related to C, this is called a transitive relation. So let us see an example. So if the example is the relation has the same birthday as. So there's a set of all people and there's this relation has the same birthday as. Now, is it reflexive? Well, of course, everyone has the same birthday as themselves, so obviously it is reflexive. How about symmetric? Yes, because if A has same birthday, for example, let us imagine, say 1st of January. So if A has birthday on 1st of January, B also has birthday on 1st of January. Now, A has the same birthday as B and B has the same birthday as A. So this is symmetric. How about transitive? So if A has birthday on 1st January and B also has birthday on 1st January. So A has same birthday as B. Similarly, if B has same birthday as C. Now we already know that B has birthday on 1st January. So obviously C will also have his birthday on 1st January. So that will also mean that A has the same birthday as person C. So 1st January is the common birthday for all of them. But the condition that if A is related to B and if B is related to C, then A is related to C is followed here, and hence this is transitive as well. So since this relation is reflexive, symmetric as well as transitive, this is called an equivalence relation. Now you can also think of some concepts from mathematics. Say consider triangles and a set of triangles where these are congruent. So every triangle is congruent to itself, so it's reflexive. Then if triangle A is congruent to triangle B, obviously triangle B is congruent to triangle A, so it's symmetric. And if triangle A is congruent to B and if triangle B is congruent to triangle C, obviously triangle A is also congruent to triangle C. So this is an equivalence relation. Thank you.